Well, hello, my legions of 8 to 12 YouTube followers. Where are we today with our Leslie Model 25 Orpheus? Well, I have pretty much finished the refinishing. I've got a couple touch-ups to do on the finish. And meanwhile, excuse the background noise. I got a space heater running on it, and tools strewn everywhere. What do we have here? Dry fitting stuff, testing the rotor balance, and beginning reassembly. So some things to note in reassembly. Let's start with the motor. As you can see, the motor is attached via two bolts that hang down from the wood here, from this deck shelf, or whatever you want to call this upper wood here. There are rubber bushings in there that should be soft and pliable to dampen as much of the vibration as possible. The belt, which is this rope belt here, is a little bit loose now because this part of the upper bearing here isn't secured until you clamp down the speaker. Now you can just run a screw, or a bolt rather, through there and secure this and test it without the speaker if you want to, fine tune it. And I recommend doing that. One of the things you want to check is the balance of this thing once you reassemble it. There's a couple ways to balance it. By the way, you notice all this fresh glue around here. That got all the rattles out of this thing. So what you want to do is check it for balance, and you're not going to be able to do that without running it. Notice that this little bolt here with a washer on it, and this one with several washers on it, this is how they balanced it at the factory. And there is one up here on the upper side as well. If the thing is really out of balance, you might have to take it out and kind of roll it to find the heavy spot and balance it manually that way. It's worth noting that there are 3 positions you can have this upper spindle in. It drives the drum. You can see it underneath there, that little tang that fits into the spots that are routed out here on the upper part of the drum. And there's 3 of those around, 1, 2, and 3. And so there's 3 different positions this wheel could possibly be in. It could be, here with the tang where my thumb is. It could be here where my thumb is now, or here. And it does seem to have an effect on the balance. When I first hooked this thing up, it was wobbling pretty good, and I took this off and turned it one thing and moved it over, and it's wobbling a lot less now. So let's pause for a second and take a look and hook that up. Now the brake circuit isn't working on this yet. I have some parts to order to fix the brake circuit, and we'll get to that, and I'll show you here in a moment what it looks like when that doesn't work and what it looks like when it does. Alright, I am positioning my phone precariously on a shelf so that I can have both my hands free. So as we see, the unit is spinning up, and the balance is pretty good. The unit's not shaking much, and since I have it up on a couple of sawhorses, it'd be shaking pretty good if it was out of balance. Let's take a look here at my little rigged up switch for on and off, and that's off. And look how long it takes to spin down. It takes several seconds to spin down. So let's start it up again. See how long. It should take about 5 or 6 seconds or so to spin up completely. And that seems about right. And it's pretty quiet. There is a little bit of a rub sound that's due to an uneven spot on the belt, so it might be time to replace the belt. The belt, this thing hasn't been used in a while either, and the belt might break in after being used for a while too. So let's go ahead and stop it again. And as you can see, the brake circuit is clearly not working. So I don't have the part to fix that now, but I can simulate the brake circuit with this 9-volt battery. This is the plug to the motor, and if I unplug, instead of turning this off, if I unplug this, it's basically going to do the same thing. The motor is going to spin down. But if I connect this 9-volt battery to it and put DC into this motor, you'll see what happens. So let's spin it up. And first, just to show you, I'm just going to unplug the motor so you can see how it spins down when the motor is just unplugged. Pretty much the exact same as before. So let's spin it up again. And this time, we'll use this 9-volt battery to apply DC to these two terminals right here, the same terminals that are the input. Okay, it's up to speed, and now we'll brake it. So, much faster. And keeping in mind that the braking voltage that this thing's going to be giving is going to be a lot higher than 9 volts. It's actually a very inefficient circuit that, that gets the voltage for this thing. It requires 225-watt resistors that get scorching hot. So if this braking circuit were working, I would not be able to touch these two resistors. No way. So let's try that again. And there you have it. So that is sort of what braking looks like. The braking will work a lot better, obviously, once we have the full voltage going to that thing. So that is basically the difference between unbraked stoppage and brake stoppage. So you could do a simple modification if you want. If you want to have the brake on or off, you know, there are multiple different ways that you could either interrupt the braking current here at the motor with a switch. You know, you could splice in a switch here, which would also turn it off, right? But when you turned it off, it would totally disable the brake. So, you know, or you could tap into here and mess with the way the relay is wired. Add another relay would be another way to do it. So you can have the braking function on or off and get that hard stop or the slow spin down as you desire. Just be careful in there. That thing's all line voltage. Anyway, so that's the first part of this. We got this good to go. The next thing to consider is bolting in the speaker, and we'll talk about the speaker next. Okay, so before we put the speaker in, you got to remove these, obviously, because those go through the speaker frame, through this, into the threaded inserts. So we'll take those out, and then this is our upper bearing here. This has to be oiled. This is a felt cube. We talked about this this little wedge of felt in previous videos. I've oiled it a couple times now, and let the oil soak in. You definitely don't want to try and soak this felt all at once, because then you'll over oil it and the thing will drip everywhere. So what I've been doing is I've been slowly feeding it oil, and I think I've gotten it almost about where it needs to go, but needs a little more oil. So I'm going to, before I reassemble everything here, I'm going to put another bead of oil right here around the edge where the bronze bearing is, and then a little out here in the side. I'm just going to let that soak in. And I'm using the Tone Wheel General Hospital rotating speaker oil, and it's got a very nice applicator, and it seals up good when it's not in use with this little cap, so that's a good oil to use. Put that aside here for a second. Okay, so this is how the speaker fits in real life. Let's talk about the speaker for a second. I picked the Ted Weber California model speaker, which is 80 watts. This one was made at 8 ohms. I mistakenly thought that the original on this was 16 ohms. To the best of my knowledge, it's actually 8 ohms. Testing has shown that the amplifier works fine driving an 8 ohm speaker. And since we don't have the original in this thing, it's kind of hard to tell what it was. But knowing that this thing's intended application was to attach to something like an M3 spinet organ, which would have had an 8 ohm speaker in it, and knowing that the way this thing gets its input signal is directly off of the 8 ohm load from the amplifier of the organ, it kind of makes sense that this would probably be an 8 ohm speaker. But anyway, that's what we got. So I picked this speaker for a couple reasons. Number one, it's recommended by Weber for Leslie applications. It supposedly has a good extended bass and also extended high frequency range. The highest note on the Hammond organ is around 6 kilohertz, and this speaker is supposedly good to 7 kilohertz, owing largely to that aluminum dome there. And looks like they had a little glue dribble there at the factory. These are all handmade speakers. Some people would get upset about that. I'm not going to get upset about it. This thing's going into a Leslie, and that is purely a cosmetic defect. If I were building a high-end guitar cabinet and was going to be showing off those bright aluminum cones or something like that, then maybe I'd be salty about it. But, you know, to their credit, they did know this was going in a Leslie, so maybe they just saw that and said, it's going in a Leslie, he'll be cool with it. And in truth, I am cool with it, so there you go. Big, massive ceramic magnet, and that aluminum dust cap, which should really boost the high frequency response. Again, this Leslie does not have a spinning tweeter, it's just got the one rotor and a full range speaker, so we need it to be as full range as it can possibly be. So we're going to bolt it on down, get the terminals facing where the wire comes in. So the wire comes into this little slot here, and we want it as close to that as possible, so we're facing it that way. Now, regarding the screws, if you don't have the originals like I don't, I got a couple of the originals. I had to procure some replacements, and these might be a little long. We're going to see. What we don't want is to pick something so long that it protrudes through the bottom and actually scratches the top of the rotor. The rotor had a couple of scuffs on it that looked like that might have happened at some point in the past. So we're just going to have to see and either get some different screws or stack up some washers. I need to find some washers for these anyway, but let's dry fit this screw with no washer and drive it all the way down and see how bad it sticks out the bottom. It sticks out the bottom about, oh, can I get that? There's no light up in there. You'll just have to take my word that it's sticking out about, 3/16, something like that. So actually, it's not going to scrape even as it is, and if I add a couple of washers to that, everything is going to be fine. So there are 4 positions on this cabinet that it mounts, here, across from there, and then there, and whoopsie, that's a strong magnet, and back there. Now, I just need to take the speaker wire off the old guitar speaker that was in there and solder it on in here. Word to the wise, pro tip: when you're soldering on a speaker like this, either turn it over, because gravity is your friend here. If you accidentally get a little too much solder on there and it drips or something like that, you know, you're soldering along, it just won't stick, and then it drips, and then you don't want it falling onto the speaker cone. Sometimes I'll stuff, you know, a little piece of paper or just any old random thing I have that's, you know, around my shop, I'll put in there just in case that happens. But, you know, that's rare, and if you're careful, that won't happen. But just be aware that it can. And there are are a myriad of ways that you can ruin a brand new out-of-the-box speaker, including, you know, slipping and running your screwdriver right through the cone as you're putting the screws in. It's very exciting getting a new speaker, but slow down and take your time so you don't lead to heartbreak. So we're going to get this speaker wired up here, and then we're going to take a look at putting the amp in there and running some test tone through this guy. Welcome back. So I decided to pull the rotor out to get the balance better, and I'm showing you a pretty simple way to do that. Basically what you want are two flat rails for either side of the pivot. On one side I'm using this shelf, using, you know, the metal rail here, and the other side I'm using a piece of wood. Not ideal. Ideally I'd want two very flat, hard surfaces, and I'd want them to be perfectly level. So actually like a pair of aluminum levels would be perfect for this, you know, set them up like this. But what you want to do is you want to set it up so that it's not rubbing on anything. And I'm going to try desperately not to knock this over, but you want to set it very gently spinning, and if you let it go, the heavy side should find the bottom, and after letting the thing settle out, we should be able to very quickly determine what side we need to add weight to. So I'm going to slow it down so it finds its spot. So anyway, this is how you balance the thing if you need to balance it, pretty much. So right now we know that what's pointing up is the lightest side, and that's more or less where those weights are. It's actually more like right about here is where we would need to add weight to get this thing to do that. Oh, sorry, bad camera work. Right about here it seems like is the top. Well, maybe closer to here. So I'm going to add a little weight there and see if we can figure out exactly how much weight it's going to take to balance this thing out. Okay, so real quick, like, I taped a couple washers to what was the spot on the top, and it is now more or less the spot on the bottom. So I got to figure out a way to split the difference. Okay, so now I've got a nut, a bolt, and a couple of washers and some tape, and it more or less wants to stay put where it is. It's close anyway. So what I'm going to do is I'm going to mark that spot with a marker, drill a little hole there, which is going to lighten it up some because it's going to take some wood out, and then between the washers and nuts and stuff, I should be able to get the weight back again. Okay, so now we've attached the new weight, and you can see it doesn't quite come up to the top anymore, but it doesn't free roll either. It does return, so we need to add, let's see, it should come back now. Yeah, so we need to add just a little more weight, maybe one more small washer. Let's try that. Okay, so with a slightly heavier second washer, I've now gotten it to where it pretty much stops wherever it stops, more or less. Given how crude my setup is, I really can't expect to get too much more accurate, but let's mount it back in there and see how the vibration is. Yeah, a little pro tip here: if you're having problems getting this lower part to go through, not such horrible light, not the rubber bushing right there, but the one that's in the bearing underneath, a lot of times you'll try to push that in, and it'll just knock the little bearing out. A little squirt of some soapy water. Oh, if I can turn the thing on. Come on, I have such horrible lighting in here. Alright. That ought to do it. I made a little mess there, but hey, it's soapy water. How bad of a mess can it be? Oh. Alright, I gotta need two hands for this. Well, what can I say? That was almost completely futile because after putting it back in, it actually made the vibrations slightly worse. And I think I know why. I think in theory, balancing it the way I did is correct, but what I failed to account on this particular rotor, let's see if the camera can catch it. You see how it's kind of warped? There's a significant amount of up-down motion, and all the balancing in the world isn't going to take the vibration out of the fact that the thing is kind of in effect bouncing up and down. You can sort of balance around that, but not completely, so we'll see. Alright, so now we have the parts to fix the brake. Here is the old 50 ohm resistor, and I'll tell you what, finding resistors in this style, the tube style with the krypton connector that goes through a hole, so you can see how it attaches. It's got a single screw that holds it on. So we've pulled back that diode and that capacitor, and what we've got here is an interesting critter. 50 ohm, 25 watt. Now you can see that this 25 watt resistor is a lot smaller than the old 25 watt resistor, and one of the reasons for that is that this, I believe, is probably only really fully rated if you mount it to a chassis. So I've drilled a couple holes there and scraped back the paint. I'm going to put some thermal paste on that, and I'm going to bolt this resistor in and get it wired up into the circuit. And I took the old, this is where the old resistor was, so I took that out and went into my grommet assortment and found a grommet that fits okay. It's a little bit large for that size hole, but it fits in there, and it'll do the job of keeping the wires from chafing on the metal. So there we go. Alright, so we got it loose fit. I haven't tightened it down or put the heat shrink compound under there. But under here, what I did was I reused the existing screw hole for the old resistor and put in a little 2-terminal strip there, which is where I tied the capacitor and diode to, and the first leg of this power resistor, and then the second leg of the power resistor goes straight to the relay. So that should fix it. Let's oh, come on, focus now. Let's put it in the cabinet and see what happens. Alright, we got it back in there, hooked up real quick, and we got our friendly Navy signal generator. So, let's see, how much better does it stop now than before? Much better. So let's see if we can time that. Oh, about 3.5 seconds. Not bad. How much slip there is in the belt will also affect how quickly it stops, but that is, I'm happy with that. So let's see, are these resistors getting hot? Oh yeah, yeah, those are getting real hot. Okay, yeah, they're 25 watts for a reason. Alright, so now we've got the braking fixed. Previous videos I covered, so yeah, that's pretty much it on the braking. We take one more look at it before we call it done. Alright, well there it is, ta-da. So, what did I do? I put some heatsink compound under it after scraping the paint away. I screwed it down. Yeah, these are long, so what? I put a piece of shrink wrap on this screw to protect this cord, even though the insulation is quite thick. And this is high temperature insulation, so it's not going to be bothered by touching this resistor at all. And there we go, soldered in place. That should do it. Oh, and I also put some Loctite on these after tightening them. Yeah, that'll make removal a real bitch. That's the next guy's problem. Seriously though, I don't want them working loose. The dissipation of this resistor really does depend on having a nice tight chassis mount. So I think we'll call that done for the brake, and we'll get that reinstalled. Oh, you know, let me show you how it works. So this is basically a half-wave rectifier tapping off of the main AC power, goes through one big-ass power resistor, 50 ohms, before going to a diode, the positive end of which and this capacitor go to the first leg of the other 50 ohm resistor, and then that is supplied to this terminal on the relay. So when this is the run/brake relay, so when it's in the run position, the motor's getting AC from the line, and when it is in the brake position, it is getting half-wave rectified DC from this power supply here, which also uses this capacitor for filtering, quote unquote, and this choke. And that's pretty much it. So if there's anything wrong in any of those components, the brake won't work. But now we have a completely rebuilt control box here, and we're ready to go.